What is rationalizing the denominator? Pretty much it is to change a denominator into a whole number without changing the value of the fraction. Why do we do this? The main reason why we are doing this today is because before the time of calculators, when math was done, it was done with the help of different tables, different resources. By tables, I mean, think about the multiplication chart. You were able to figure out what 12 times 12 was really quick when using the multiplication chart. Very similar, there were tables for the square roots of certain numbers, but there was no tables of when a fraction had a square root as the denominator. Mathematicians said, you know what? We do have tables for square roots for the numerator. All we got to do is just change it. That way we can continue our math. That's the reason why we rationalize the denominator. How do we rationalize the denominator? Pretty much with a square root, we are going to multiply our given fraction with a second fraction. The second fraction is going to be pretty much 1 because the second fraction is going to be the denominator of the given fraction over itself. So I've already made a mistake in spelling. It shows it in there. But we are going to use two properties that we need to recall for us to remember and do our work properly. The first property is this one right here, when we have the square root of two factors or two numbers being multiplied together, a times b. We can split that up as the square root of a times the square root of b. We can go backwards as well, or from right to left. From here, if we have two different square roots, we can join them together and have them multiplied under one radical. Very similar with multiplication, we have division. If I have the square root of a divided by b, I can break this down into the square root of a divided by the square root of b. And vice versa, I can go backwards or from right to left as well. If I have the square root of a divided by the square root of b, since they both are inside a square root, then I can put them both under one square root as just a fraction of a over b. Of course, here, a and b are representing numbers, all right, whole numbers, positive whole numbers. From 1, I add to as large as you can. They cannot be 0 or negative numbers. Right, we are going to simplify. Instructions say to simplify, but in this case, we have a square root as part of a denominator. In example 1, we don't have that right off the bat, but we need to work towards it. That way we know that we have a square root or a radical as our denominator. So let me zoom in a little bit. So simplify the square root of 16 divided by 6. Before we start trying to figure out what are we going to multiply this by, let's simplify the inside fraction first. So we're going to end up having the square root of 8 over 3. All I did was just simplify the 16 over 6. I divided both by 2. Now I am going to use this property right here. That way I can split up this square root. So I am going to have the square root of 8 over the square root of 3. The reason I'm doing this is because I want a square root as a denominator. That way I know which fraction do I need to multiply or to create in order to multiply the square root of 8 over the square root of 3. All right, so I'm going to multiply this by a fraction. What fraction is that? Well, since my denominator of the simplified at the moment is the square root of 3, my new fraction is going to be the square root of 3 over the square root of 3. From here, I am going to have the square root of 8 times 3 over the square root of 3 squared. So what I've done is I applied this portion to go into here. Here's 8 and 3. So think about it as a and b. A times b. And then 3 times 3, instead of writing 9, I put 3 squared. The reason for that, I'm going to show the step in a way in terms of how I like to take square roots. All right, so this is going to become the square root of 24 over the square root of 3 squared. Now, square root of 24. So how does that pretty much break down? I need to break that down, right? So simplify that. So 24 is going to be broken down. What two numbers multiply to get us 24? Well, I used 8 and 3, right? To get to 8, I have 4 times 2. And then 4, I have 2 times 2. I'm going to circle 3, 2. I should have circled them as soon as I got them because they are prime numbers. All right, so now the square root of 24 becomes the square root of 2 squared times 2 times 3. And the square root of 3 squared. The reason I wrote 2 squared only once because I only have 2 2's, 1 2 and 1 3, 1 2 and 1 3, right, for it to make 24. All right, so now I'm going to end up using this property on this part right here. So that is going to become the square root of 2 squared times the square root of 2 times 3 over the square root of 3 squared. The reason I'm doing this is because this square and the square root technically will reduce each other out. Same thing with those two. So now this becomes 2 times the square root of 2 times 3 over 3. All right, the inside of the square root, I'm going to multiply it. This is what I mean by the inside. 2 times 3 is 6, and then over 3. Now, be careful because some of you might want to reduce the 6 and not 3. You cannot reduce that, all right? Why? Because the 6 is inside the square root. Think about it this way. 6 is protected by the square root, so you cannot touch this 6. Right, if these two were be able to reduce, then you will be able to reduce those, but not the 6. All right, example 2. We are asked to simplify the square root of 2 over the square root of 5. This one's a little bit easier because we already have the square root in our denominator. So I'm going to know now what fraction am I need to multiply. What's the denominator? The square root of 5. So that's my new fraction that I'm going to multiply. The square root of 5 over square root of 5. So that's going to become the square root of 2 times 5 over the square root of 5 squared. Again, the square root and the square reduce each other out. I can multiply those two numbers together. So I'm going to have the square root of 10 over 5. The 10 is protected by the square roots, so I cannot reduce the 10 and the 5. So please be careful with that. All right, let's move on to example number 3. Example number 3, we are asked to find the area of a rectangle. How do we find the area of a rectangle? Area of a rectangle equals base times height. In this case, the base is going to be the square root of 5 over 2. And the height is the square root of 3 over 5. So the area equals the square root of 5 over 2 times the square root of 3 over 5. All right, so I'm going to use this property right here to go from here to this part here for both of the fractions. So I am going to have area equals the square root of 5 over the square root of 2 times the square root of 3 over the square root of 5. All right, so some of you might be able to do some reduction here or simplify some stuff out. I'm going to do this the long way because it's the safest way to go. So now I'm going to combine, right, the square root of 5 times 3, the square root of 2 times 5. So area equals the square root of 15 over the square root of 10. Now that I have this, now I can multiply the square root of 15 over the square root of 10 by the square root of 10 over the square root of 10. So I'm going to continue my work over here. So area equals the square root of 15 over the square root of 10 times the square root of 10 over the square root of 10. So now I am going to have area equals the square root of 15 times 10 over the square root of 10 squared. 15 times 10 is 150. All right, so now I need to break down 150. Well, I know I used 10 and 15. To get to 10, it's 5 and 2. 2 and 5 are already prime numbers. To get 15 is 3 times 5. All right, so this is how I'm going to break down the square root of 50. Area equals the square root of 2 times 3 times 5 squared over the square root of 10 squared. All right, so again, the square root of 5 squared times the square root of 2 times 3. I'm already thinking that in my head. Square root and square reduce each other out. So I have area equals 5 times the square root of 6 over 10. Again, the 6 is protected by the square root, but not the 5. We are not adding anything in both numerator and denominator, so that means that I am able to reduce this 5 and this 10. So our final answer to this area is going to equal the square root of 6 over 2. Or if you want to include the 1 can be in there as well. 1 times the square root of 6 over 2. All right, our last example, example number 4. We are asked to simplify 4 times the square root of x times y to the 4th all over the square root of 5x squared y cubed. Personally, the variables are easier to work with than the actual numbers. In this case, the numbers 4 and 5 are already prime, or 4 is already outside. So all I'm going to have to worry about is the variables. This is already outside, so I'm not going to worry about that. 5 is already a prime number. I cannot take the square root of 5. All right, so I'm just going to be concentrating creating groups of 2. So I am going to have 4 times x times y squared over the square root of 5x squared y squared times y, or y to the first. We have a total of 4, so 2 plus 2 is 4. Of the y's, we have a total of 3 y's, 2 plus 1, since they have the same base. 2 plus 1 is 3. So from here, I'm going to rewrite 4 square root of x times the square root of y squared times the square root of y squared over the square root of 5 times the square root of x squared times the square root of y squared times the square root of y. I'm going to continue right below in black. So I'm going to have the square root and the square reducing each other out. They're creating ones. So in black, I'm going to be ending up with 4 times the square root of x times y over the square root of 5 times x times y times the square root of y. Now to rearrange stuff, since these are outside, I can multiply that with the 4. I'm going to get 4y squared. And then the square root of x all over xy times the square root of 5y. Oh, I'm not done there yet. All right? Not done there yet. Why? Because this square and that y, I'm able to reduce out. So the actual final answer is 4y times the square root of x over x times 5y. And that is our final answer.